All right. If you've been following along with me in order, then you know that we've done a lot of Lewis structures and a lot of molecular geometric properties. And so CLF4 plus is our last one. And so let's go ahead and approach it systematically the same way we've done every time. Start off by counting up those valence electrons. Get 7 from the chlorine and 28 from the fluorines. That positive charge means that I should subtract 1 because it's a +1 positive charge. I'm left with 34 valence electrons. So arranging the atoms on the page and then drawing a single bond from the central atom to each one would give me a recount of valence electrons left at 26. Let's go ahead and get those lone pairs going to make octets around fluorine. And I will have used 24 valence electrons for that, leaving me with 2 left. Now, chlorine can do an expanded octet, and so I'll add that electron pair right there on the chlorine to get that expanded octet, and now everything's got octets. Let's finish it out with some brackets and a charge on the outside of the brackets to finish up the Lewis structure. Okay, electron geometry. I've got 1, 2, 3, 4 bonds and a lone pair, so that's 5 geometry groups, which means it's trigonal bipyramidal electron geometry. Now, from trigonal bipyramidal electron geometry with 1 lone pair, I get seesaw molecular geometry. Bond angles are both 190 and 120, depending on where in that structure they are. And for polar and nonpolar, again, it's an ion, so that's not applicable. And the ion intermolecular forces would just be ion forces. Now we can determine hybridization. Again, that's based on electron geometry. Trigonal bipyramidal means sp3d hybridization. 4 single bonds only means 4 sigma bonds. No double bonds, no triple bonds means no pi bonds. So 4 sigma and no pi. That's CLF4 plus.